Hello everybody. So today we are going to start with the next topic, that is electrochemical series. As you all know well that the electrochemical series is the arrangement of the different metal in the decreasing order of their standard reduction potential. And dear students, in the previous video we have seen that this standard reduction potential we get by coupling the particular metal electrode with that of simple hydrogen electrode. That simple hydrogen electrode is also known by different names like reference electrode, standard hydrogen electrode, reversible electrode, inert electrode, like so on. So let us recap quickly the previous topics. So this is the simple hydrogen electrode we have. Just combine this So dear students, you can see here this is a simple hydrogen electrode which we are using here as a reference electrode to find out the electrode potential of the zinc electrode. So zinc electrode is more reactive than the hydrogen electrode, so it is being getting oxidized here, and we can see here that we are using here a voltmeter to find out the electrode potential, and you can also use one more gadget here such as galvanometer, which gives us the direction of movement or flow of current. So it flows from right to left hand side, means from cathode to anode, right? So the next thing is, so dear students, in the previous video we have seen that we have calculated the standard electrode potential of the cell as positive 0.76 volt using the hydrogen electrode. So what we know that we write the standard electrode potential only for the reduction reaction. Means here in this reaction you can see that zinc is being getting oxidized into zinc 2 positive ion, but in order to write the standard electrode potential we have to write the reverse reaction, and this is the reverse reaction you can see. And for this reaction the value of zinc standard electrode potential of the zinc gets reversed and it comes out to be minus 0.76 volt. So similarly you can see in here that we can calculate the electrode standard electrode potential of different metals and arranging them in the decreasing order, so we can compare their reactivity thereafter. So this is the electrochemical series of different metals, and they are arranged one after another. The you can see here these standard reduction potential values are calculated at standard condition, that is temperature is about 298 Kelvin and the value of the pressure is 1 bar if there is any gas involved, and the concentration of the electrolyte at which the particular metal electrode is dipped is always kept to be 1 molar. So you can see this. So dear students, in this electrochemical series you can see that the standard reduction potential of the hydrogen is 0 volt. It is 0 volt. So there are some reactive metals, they are lying just below the hydrogen, and the most reactive metal that is very prone to get oxidized is lithium. And on the upward side of the hydrogen are the metals with positive reduction potentials, and at the top there is fluorine which is having the highest reduction potential. It means that fluorine is having much more tendency to get reduced, and it has very less tendency to get oxidized. So dear students, we have seen that as we move upward from the hydrogen in this electrochemical series, there are the metals with positive standard reduction potential values and the non-metals with very high uh, tendency to get reduced, and therefore they are acting here as a strong oxidizing agents, right? Or on the other hand, as we move downward from the hydrogen, there are the metals only, and these are having negative value of the standard reduction potential, and they have more chances to get oxidized, and therefore they act as a strong reducing agent. So these are the two main points to remember here, that in from above the hydrogen there are the strong oxidizing agents which have the tendency to promote the process of reduction, whereas in as we move downward there are the metals which have only the tendency to get oxidized. So dear students, while studying this electrochemical series in detail, we have come to the conclusions that the metals which are lying below the hydrogen have the tendency to liberate hydrogen gas when they are reacted with the acids like HCl, right? So only the metals which are lying below the hydrogen, they can release the hydrogen gas when reacted with the acids like HCl or any other acids like H2SO4. Similarly, sometimes the question comes in the exam that why copper 2 positive do not liberate hydrogen when it is reacted with the acid. So you can write the simple answer for this question, that the standard reduction potential of the copper, it is positive and it is lying just above the hydrogen, so it cannot reduce the hydrogen gas, or it cannot liberate the hydrogen. Similarly, many more question comes in the exams from this electrochemical series, that can be place the nickel sulfate or nickel chloride solution in the any other metal. We can take that silver container. So what will be your answer? The question is clear. Can we place the nickel 2 positive ion or nickel sulfate or any other salt solution of this particular metal in the silver vessel? What will be your answer? So we can find the conclusion here that nickel is more reactive than the silver, and nickel has more tendency to get oxidized. Nickel has a tendency to get oxidized because it is having negative standard reduction potential value, whereas copper or this silver metal, it is having positive value of standard reduction potential, so it is stable and it is in the metallic form. So we can place this nickel metal in the silver vessel. But on the other hand, if the question comes in the exam that can be place this copper sulfate solution in the zinc vessel. And the fourth point is regarding the selection of cathode and anodes for making the electrochemical cell. Electrochemical cell. So for the preparation of the electrochemical cell, we require two electrodes. One is cathode and one is anode. So anode must be very reactive, having very high negative reduction potential value, and cathode must have a positive standard reduction potential values. So if we are given some problem that can you construct a electrochemical cell in which the cathode is acting as an anode and nickel is acting as a anode. Is this reaction is possible? Yes, this is possible because anode is having a negative standard reduction potential value and cathode is having a पॉजिटिव स्टैंडर्ड रिडक्शन पोटेंशियल वैल्यू। लेकिन अगर हमारे को ये रिवर्सल इसका कॉम्बिनेशन दे दिया जाता है कि अगर आपको निकल का कॉम्बिनेशन दे दिया जाता है जिंक के साथ, जिसमें निकल जो है वो एनोड है और जिंक को दे दिया जाता है एज अ कैथोड, तो नाउ is this combination is possible when you calculate the E naught of the cell, which is according to the formula E naught of the cathode minus E naught of the anode, then you will come to the conclusion that resultant value cathode आपके पास हो जाएगा जिंक पॉइंट minus 0.76 volt and anode it is 0.25 minus 0.25, so it will come about to be minus 0.51 volt. So we can see here that the resultant value is negative, so which gives us the idea that this particular combination of electrochemical cell cannot. So dear students, these are the some of the applications of the electrochemical series, and we have now come to the exact conclusion that the value of the standard reduction potential of different metals is calculated with the help of simple hydrogen electrode, right? Simple hydrogen electrode is also known as standard hydrogen electrode and reference electrode and reversible electrode. All the names are given to the simple hydrogen electrodes on the basis of its different functions, right? Now the next topic is Nernst equation. So what is the reason for the involvement of this Nernst equation in the electrochemistry? Dear students, we see that the standard electrode potential of the different metal is calculated in standard conditions, means temperature is 298 Kelvin and the pressure is 1 bar. If there is any gas involved, then the pressure is 1 bar. So dear students, these are the few applications of the electrochemical series, and now we have come to the conclusion that the different values of the metal electrodes are calculated with the help of simple hydrogen electrode, or we can say standard hydrogen electrode, which is also reversible in nature and also known as reference electrode and also known as inert electrode, because the platinum metal present in the form of the platinum foil does not take part in any chemical reaction, right? So the main reaction involved is because only with the hydrogen ion and the hydrogen gas. Sometimes hydrogen gas gets oxidized into hydrogen ion, and on the other hand sometimes it gets reduced, the hydrogen ion gets reduced into hydrogen gas. So these values are obtained at standard conditions of temperature and pressure, and the standard condition of the concentration of the electrolyte, that is 1 molar solution. So what will be the impact on the E naught of the cell if the concentration of the cathode and anode is not 1 molar, it is not 1 mole, then whether the E naught of the cell will increase or decrease. So to get the exact value of this question, we have to introduce the new equation that is called Nernst equation. Nernst equation is applied when the concentration of the electrolyte in the 2 half cell is not exactly 1 molar, and it sometimes the electrolyte gets diluted as the reaction goes over. So let us come to the next topic.